Same outfit, just give you a little bit different view this time as I'm going through. The last section of chapter 7 that we are going to take care of is section 7.4. We've dealt with adding and subtracting rational expressions with like terms, unlike terms. We've simplified them. We found least common denominators. We've done all of those different types of things with expressions. The next thing that we're going to do now is we're going to work on equations and how we go about working with rational expressions. So a few parts of today's lesson. We're going to determine the domain a little bit, just for a few seconds, of the variable in a rational equation. Big part we're going to do for today is we're going to solve rational equations. That's going to be a big part of today. Recognizing the graphs and solving them with a graphing calculator. It's not something that we are going to do and we're not going to worry about. We're just going to worry about really solving the equations and making sure we can figure out what the domain is and how we go about eliminating some of the variables. So we talked about rational expressions, and we said rational expressions were the division of two polynomials. Okay? An equation, or a rational equation, is an equation that contains at least one rational expression with a variable in the denominator. Now notice it says variable in the denominator. In order for it to be a rational expression, that variable does need to be in the denominator, and we really are going to have to worry about that variable that's in the denominator, because remember, we can't divide by 0, so we're going to have to check for solutions a little bit more when we're solving equations to make sure that we can do those different types of things. This is really like bugging me. But anyway, so we're going to determine the domain of the variable. So just kind of look at them like we did before. We've talked about domain. Just going to kind of reemphasize that here first, and then we'll work on solving them. So for example 1, if we're talking about what the domain can be for this example. So we've got 3 over x plus 1/4 is equal to 9 over x to the 4x. So the directions say, it says the domains of 3 rational expressions are, since we can't divide by 0, the domain for the first one is all reals except for 0. The second one, it doesn't matter, it's negative infinity to infinity. And for the last one, it's also x can't be 0. So what we're looking for when we're talking about domain is we're talking about really the intersection of these 3 domains. And the intersection of these 3 domains is all real numbers except for 0. So if we're looking at the domain for this, our x value could be anything except for x is equal to 0. Second example, we're going to find the domain. So again, when we're talking about finding the domain, we're talking about that denominator where it can't be 0. It's going to be all real numbers except for kind of that intersection. So if you remember from back when we did this in 7.1a, we had to factor first. So we had to factor everything. So if we factor this is x minus 2, x plus 2. And then we said, okay, what makes that 0? Well, 2 makes that 0. What makes that 0? Negative 2. And then what makes that 0? Negative 2. And what makes that 0? 2. So when we're talking about the domain for this one, the domain for this is going to be x such that x does not equal 2 or negative 2. So it can be anything else but 2 or negative 2. So when we're solving equations, if we were to get 2 as one of the answers, that can't happen because that would make that one equal to 0. So really we're finding what are called the excluded values or the extraneous solutions. Solutions that don't actually work in there is what we're doing when we're finding that domain. So they got x such that x is equal to plus or minus 2. Okay, so that's the domain. And we got to be able to find that domain so that when we solve the equations, we have to be able to figure out what x values can't work. So when you're solving equations, the easiest way to solve most rational equations is to multiply all the terms in the equation by the least common denominator. So just like what we did before, we're going to find that least common denominator and we're going to add them all. Okay. This step will clear the equations of all denominators, and then it's necessary to check the proposed solutions, blah, blah, blah. Okay, so it's gonna be done a little bit different than we did those, and I'm gonna show you a different way to do it rather than just adding and subtracting them. We're gonna instead find that least common denominator, and we're gonna kind of multiply it out. Now, caution. When both sides of an equation are multiplied by a variable expression, the resulting proposed solutions may not satisfy the original equations. You must either determine and observe the domain or check the proposed solutions in the original equation. Okay, it's wise to do both. We'll talk about what that means here after this one. Okay, so let's say that we're going to solve negative 3/20 plus 2 over x equals 4 over x. The first thing we're going to do is we're going to find the least common denominator. So I'm going to list that least common denominator. Well, I look at my numbers, and we've got 20 and 4. So what's going to be a common denominator for them? Well, 4 times 5 is 20, so that's going to work. So our least common denominator is going to be 20, and then we've got an x in there. Okay, so now when they explained how we're going to go about doing this, and I do like how they do this when they solve equations, they said to take each of the terms times the least common denominator. So I'm going to take my least common denominator, 20x, and I'm going to take that times negative 3/20, plus I'm going to take my least common denominator, 20x, times 2 over x, and that's going to equal my least common denominator times 5 over 4x. Okay. Now, we're multiplying rational expressions. So remember, when we multiplied rational expressions, we can reduce if we need to. Okay, so this is like 20x over 1, so I've got a 20 in the numerator and a 20 in the denominator, so they cancel each other out. So I'm left with x times negative 3, so that's negative 3x. Plus, now if I take 20x times 2 over x, that's like 20x over 1, so the x's are going to cancel each other out. 20 times 2 is 40. That's then going to equal 20x times 5 over 4x. The 20 and the 4 can reduce. The 20 can become a 5. 20 divided by, and the x's can go away. 5 times 5 is 25. Now I have an equation, negative 3x plus 40 is equal to 25. Now I can solve that equation. Subtract 40 from both sides, divide by 3, and we get a solution of x is equal to 5. Now, we have to make sure that that 5 is okay. What do I mean by okay? We have to check to see if it works. We have to check to make sure that in our original equation, that if I put 5 in for my x values, that I don't get a 0 in the denominator. And if you notice, if I put a 5 in here, I get 2/5, and in there I get 20. So nothing's wrong, so that's okay. So that is the solution to this problem. Okay, so when you're doing these, it's nice to find that least common denominator and then take each term times them. And you'll notice then the denominator kind of goes away. There's a different way to do these, and kind of how I did when I added them, how I just compared denominators, but it's the same thing. And I actually like this way a little bit better than sometimes how I have done this type of problem. So again, let's just kind of review how they did it. They wrote it a little bit differently. I don't like to write it like they wrote it, because sometimes you forget to distribute that 20x into the 2 divided by x. So I like to write it out a little bit longer than they do, but do what you're comfortable, but just be aware that that 20x has to be distributed, and it can cause some issues. So that's why I wrote it down the way that I did. And they got the same solution that I did. And again, it's a proposed solution. We have to check to make sure it works, and we did that. So that's our solution. Okay, so let's go to the second one. So we've got 3 over x plus 1 equals 1 over x minus 1 minus x squared over negative 1. So we have to find that least common denominator, so LCD. So in order to find that LCD, we got to make sure everything's factored. X plus 1 is factored, x minus 1 is factored. This has got to be x minus 1, x plus 1. So we start out on our left and then go to our right. So x plus 1, x minus 1, and then we've got x plus 1 and x minus 1 repeated. So that's going to be my least common denominator. To solve equations, then we have to take each term times that. So I'm going to take x plus 1, x minus 1 times 3 over x plus 1. That's going to equal, because that's an equal sign there, x plus 1, x minus 1 times 1 over x minus 1 minus x plus 1, x minus 1 times 2 over x squared minus 1. Excuse me. All right, so remember that this is just like over 1, so we're multiplying, so we can cross out, cross out, cross out. So that leaves me with 3 times x minus 1. So 3 times x is 3x. 3 times negative 1 is negative 3. Equals, the x minus 1s now are going to cancel each other out, leaving me with x plus 1 times 1, which is just x plus 1, minus, now I'm going to put a parentheses after the minus. Now, this x squared minus 1, remember that that was x minus 1, x plus 1. So those are just going to cancel out, so I'm just left with minus 2. Now we're going to solve the equation. So combine like terms. I'm going to subtract 1x from both sides, so that's 2x. I'm going to add 3, so I get x is equal to 1. Now, this 1, again, is just my proposed solution. It could possibly be a solution, but I need to put it into the original and see if it makes one of my denominators 0. So if I plug it into the first one, 1 plus 1 is 2, so it would be okay. If I plug it into the second one, 1 minus 1 is 0, so that doesn't work. So that means that x equals 1 does not work. Since there are no other solutions to this, then our answer is no solution. There are no solutions to this because our proposed solution can't be a solution because it makes one of the denominators 0. And you always, always, always have to check that. Okay, let's see how they do it. Again, they wrote it to save some space. You just have to be careful when you do that. Okay, so they got the proposed solution. Since the proposed solution is not in the domain, it cannot be an actual answer. So therefore, there are no solutions. So it is the empty set. All right, let's look at another one. So we've got 4 over x squared plus x minus 6 minus 1 over x squared minus 4 equals 2 over x squared plus 5x plus 6. This is going to be a long one. All right, so step 1. I'm going to find the least common denominator. That means I need a factor. So we could do the x thing. We should be getting away from that. So that's x plus 3, x minus 2. Difference of squares. So x minus 2 times x minus 2. And then this is x plus 3 and x plus 2. So that makes my least common denominator. Start at the left. X plus 3, x plus 2, oops, sorry, x minus 2, Go to the next set. I've got an x minus 2 and an x minus, oops, that should be x minus 2x plus 2. That should be factored x minus 2x plus 2. So that gives me an x plus 2. I go to the third one. I've got the x plus 3 already. I've got the x plus 2, so there's my least common denominator. So that means I'm going to take each of these times my least common denominator. Okay, so now, maybe save some writing, because that's a long common denominator. So let's just compare. If I compare this denominator to that denominator, what's not there? I've got the x plus 3, I've got the x minus 2, I don't have the x plus 2. So that means I would need to take this times x plus 2. So what you do to the numerator, you do to the denominator. Compare. What's different? Well, the x plus 2x is the x plus 3, so that means I need to take this times x plus 3. Got that minus sign in there, so that's going to cause me some problems. So be careful with that. And now compare the last one. I've got x plus 3 and x plus 2, and that means I don't have an x minus 2. This is just a different way to do it. Save some writing. So I don't care about the denominator. Notice how in the last problems we had the denominator went away? Same thing, denominator goes away. So we've got 4 times x is 4x. 4 times 2 is 8, so plus 8. Minus, so I'm going to put a parentheses. Anytime you put a minus, make sure you put a parentheses. 1 times x is x. 1 times 3 is 3. Equals 2 times x is 2x minus 4. Combine like terms. 4x minus x is 3x. 8 minus 3 is 5. Subtract 2, subtract 5, get x is equal to 9. That's a possible solution. You plug it in there, negative 2, 2, so none of those are going to be 0. So our solution, x is equal to negative 9. And it works. Okay, this is just a different way to do it. If you're comfortable doing it this way instead of the other way, that's 100% fine, especially when you get these longer ones instead of writing it out like they're going to do. And I'll show you how they do it just so you can see another example of how they're doing it. Sometimes it's a little bit easier to not write so much. So they've got this long thing, okay? So there's theirs. And again, see how they did it? And I cancel some things out. The proposed solution is negative 9. And it works, so our solution set is negative 9. All right, last one that we're gonna do. And my camera, just went into, I only have 10% on my phone. I think that happened on the last lesson too, and I plugged it in for a while. Whatever. Okay, so we've got 2 over x plus 3 minus 1 over x minus 1 equals negative x squared minus 3x. There's an x squared in here. So when I look at this one, what I'm thinking of is, okay, could we possibly maybe simplify this first? If I look at that third term, the negative x squared minus 3x over x squared minus. So if I'm going to take this part, because it looks ugly, I want to see if maybe I can reduce that. Does that reduce to something different? So if I factor that top, I can take out a negative x. And if I take out a negative x, that leaves me with x plus 3. If I factor that bottom one now, that's x plus 3. Yes, x minus 1. So because they're in the same one, I can go ahead and cancel those two out from each other. And that's going to save me a ton of time with how we go about solving this. So in a sense, the problem we have here is 2 over x plus 3 minus 1 over x minus 1 is equal to negative x over x minus 1. So we're going to find the least common denominator. Make sure everything's factored. It already is, so it's going to be x plus 3 and x minus 1. I don't like how I wrote that. Okay. So that means I need to take x plus 3 times x minus 1 times each of the terms. Okay, so that's doing it this way. Again, I did it like I did the old one again. Nothing wrong with that. So the x plus 3's are going to cancel each other out. And again, if you're thinking about the last time, how would you look at it? If you compare the denominators, what's different? The x minus 1. Notice what's here. It's the same thing. So that would be 2x minus 2 minus, so we're going to put a parentheses. The x minus 1's cancel, so that leaves me with x plus 3. And again, I would put x plus 3 there if I was just comparing the denominators. Equals, the x minus 1's cancel each other out, so we've got negative x times x, so that's negative x squared. Negative x times 3 is minus 3x. And again, I would take this times x plus 3. Combine like terms. So 2x minus x is just x. That's a big deal. Minus 2, that's minus 5. Equals negative x squared minus 3x. Ah, this is better. So move the x squared to the outside, so that's x squared. 3x to both sides, so 3x plus x is 4x. There we go. Minus 5 equals 0. Now that factors to x plus 5, x minus 1. So our solutions are negative 5 and 1. Now those are our possible solutions. We need to check them. If I put a 5 in there, I'm okay, but if I put a 1 in there, that becomes 0. So 1 is not a solution. Our only solution to this is negative 5. Okay, so sorry about that. Made a little error in there, but we fixed it. That happens. Reason, I mean, I looked at it and said, ooh, quadratic formula, I don't really want to do that. I don't think they would do that. So I went and checked my math. In math, it happens sometimes. So just be a little bit careful when you're doing these. So least common denominator, same thing we did. Eventually you got the same answers we did. They checked for possible solutions. And said x couldn't be 1. So our only solution was negative 5, which I think is what we had. Okay, so that's solving equations. This is a long video, sorry, about 27 minutes, but you have a couple days to do this. So that was solving equations, and that does finish up this chapter as well. So yeah, about a 4-day cycle. So we'll be looking at taking a quiz over chapter 7 sometime early next week when you're ready to take the quiz. Probably do the rest of the assignment today, and then you could probably take it tomorrow, which would be Friday, if you're in building. If not, we can work on getting it taken care of. But there is chapter 7.